Hi everyone, my name is Xingyuan Wang. You can call me Rebecca. Today I want to share my investment strategy with you guys. Right now I have 20 stocks. You can see here, like Citi, Yahoo, JP Morgan Chase, MetLife, Disney, eBay, Louis Vuitton, Oracle, and Facebook. I collect those stocks from different markets because I really want to have a diverse portfolio. And all of those stocks starts from January 3rd, 2014 to October 30th, 2014. I write some simple R code to get those data. Here is my code. I just hope all of those data could be enough. Okay, basically I'm just using efficient frontier model to analyze my investment strategy because I think it's very helpful and much easier to calculate. I mean, you can just use Excel function and solver to get the whole idea. For me, I'm not good at writing code, so other strategies might be a little bit complicated for me. So I think efficient frontier model is the best strategy for me to use. So first, I need to calculate average return and standard deviation for each stock. Here it is. Look, I highlight it as yellow, so you can see average return and standard deviation for each 20 stock. It's very easy to calculate it, and you can just use some basic Excel function to get it. Then here comes the difficult part: covariance for 20 stocks. Yeah, it is. Look. Just use the function equal covariance and put arrays inside it. I think when you get familiar with the covariance function, you will find it's very easy to calculate it. When I get covariance matrix, I can begin to calculate the variance and the standard deviation of my portfolio. Before plug those parameters into the formula, I want to show you what the formula looks like. This one, here it is. So you say it looks a little bit complicated, but when you use Excel function to calculate it, it looks much simpler, I think. The MMULT function is a function to calculate. It's like a product, calculate the product of matrix. Yeah, it looks like a little bit hard. I think it's much easier. Then just use SQRT function to get the standard deviation of my portfolio. So when I get the variance and the standard deviation, kind of like finished off those preparing parts and begin the solver part. Before the solver part, I want to introduce something. You see here it is, constraint column. I want the total weight of my portfolio to equal to 1. So I set up this constraint here, and the expected return. I want this Q2. I have one condition that Q2 equals to P2. So actually I set up this expected return as my set objective cell. But here, in this one, it looks like the set objective is standard deviation, but it's actually they're same, so it's not gonna influence my result. So yeah, and the weight is my the changing variable here is my weight. Look, I highlight it as red, so this is my result. And when I use solver, I kind of like use solver seven times. So the first time I set up the expected return is 23%, and I get the first result. And the second time I just set up it as 3%, and I got another result, another weight combination. So I use 7 times to get 7 different combinations, and I put all of those combinations here. We can see I set up the expected return like 3%, 4%, 6%, 16% to see the difference between the change of the standard deviation, and those as difference between weight combinations. When I have those days, 7 different standard deviation and the average expected return, I use those data to draw this graph. Here it is. So YXL is the expected return and XL is risks. It means under different expected return, I can easily get the minimum risks and decide whether it's gonna be a good strategy or not, because points on this efficient frontier is the best portfolio. So for example, if the expected return is 20%, the minimum variance is kind of like 13%, or between 13% and 13.5%. So risks bigger than this one it's not gonna be a good portfolio. It means it's not gonna be a good portfolio. So it's the most efficient way to decide whether it's gonna be a good strategy or not. So this is my presentation today. So thanks for your time, and have a nice day.